Hello and welcome. This class is titled Heat Illness: How to Prevent. The following training class is provided by University of Kentucky Health and Safety Department. I am Jason Burns, Safety Specialist from Health and Safety. Heat illness can be deadly. Every year, thousands of workers become sick from exposure to heat and some even die. These illnesses and deaths are preventable. So, who is affected? Workers exposed to hot and humid conditions are at risk of heat illness, especially those doing heavy work tasks or using bulky protective clothing and equipment. Some workers might be at greater risk than others if they have not built up a tolerance to hot conditions. This can be anything from workers outside at the farm to workers inside at a heating plant. The objectives for the class are defining heat illness, determine the causal factors of heat illness, define heat disorders and health effects, discuss ways to prevent and control heat illness, define the types of engineering controls that can be used for heat illness issues, and define different types of work practice controls. Also, the class will discuss the different types of PPE that can be used, provide a definition of acclimatization, define reacclimating, and discuss administrative controls or work practice controls. One of the definitions that everyone should understand is heat illness. While working in the heat, the body normally cools itself by sweating. During hot weather, especially with high humidity, sweating isn't enough. Body temperature can rise to dangerous levels if precautions are not taken. Heat illnesses range from heat rash and heat cramps to heat exhaustion and heat stroke. Heat stroke can result in death and requires immediate medical attention. The four environmental factors to be considered when discussing heat illness are temperature, humidity, radiant heat, and air velocity. Temperature is considered to be ambient air temperature. Humidity is the amount of moisture in the air. Radiant heat is heat such as from the sun or a furnace. Air velocity is considered to be circulating air. The following are causal factors that should be considered: age, weight, degree of physical fitness, degree of acclimatization and metabolism, the use of alcohol or drugs, as well as a variety of medical conditions such as hypertension, all affect a person's sensitivity to heat. Other causal factors that should be considered are: has the employee had a prior heat injury? Prior heat injuries could predispose an individual to an additional injury, and the type of clothing that must be considered. The following is the heat equation taken from the American Conference of Governmental Industrial Hygienists, ACGIH. The heat equation states that high temperature plus high humidity plus physical work equals heat illness. The picture signifies the combination of relative humidity and temperature that is considered to be dangerous, which is the red area, where you should use caution, which is the orange area, and also the less hazardous, which is the yellow area. Understanding the heat index. The U.S. National Oceanographic and Atmospheric Administration, NOAA, developed the heat index system. The heat index combines both air temperature and relative humidity into a single value that indicates the apparent temperature in degrees Fahrenheit, or how hot the weather will feel. The higher the heat index, the hotter the weather will feel, and the greater the risk that outdoor workers will experience heat-related illness. NOAA issues heat advisories as the heat index rises. The heat index can be used to help determine the risk of heat-related illness for outdoor workers, what actions are needed to protect workers, and when those actions are triggered. Depending on the heat index value, the risk for heat-related illness can range from lower to very high to extreme. As the heat index value goes up, more preventive measures are needed to protect workers. Heat index values are divided into 4 bands associated with 4 risk levels. These bands differ from those appearing in the NOAA heat index chart, which was developed for the public. The NOAA bands have been modified for use at work sites. According to the heat index rating, the following steps should be taken in response to an elevated heat index. Develop an illness prevention plan for outdoor work based upon the heat index. Train your workers how to recognize and prevent heat-related illness. Track the work site heat index daily. Communicate it and the required precautions to workers, and implement your plan. Review and revise it throughout the summer. The following are disorders that could result from working in the heat: heat rash, heat cramps, heat exhaustion, and heat stroke. Heat rash. Heat rash is one of the most common problems in hot working environments. Some of the symptoms of heat rash are prickly heat is manifested as red papules and usually appears in areas where their clothing is restrictive. Sweat cannot freely evaporate from the skin and sweat ducts become plugged. Heat rash can be prevented and treated. Prevention. You can prevent heat rash by wearing breathable clothing and also thoroughly cleansing the skin. Treatment. You can treat heat rash by keeping the skin dry, by using cooled sleeping quarters, and also by using calamine lotion. Heat cramps. Heat cramps may result after excessive water loss, sweating, or dehydration. Some symptoms of heat cramps are shriveled skin, sunken eyes, dry mouth and tongue. Also, severe pain and cramps in legs and abdomen, fainting or dizziness, weakness, profuse sweating, and headaches. Heat cramps can be treated by increasing fluid intake, increasing salt intake, resting, and moving to a cool place. Heat exhaustion. With heat exhaustion, blood moves toward outer body to remove heat. Blood can pool in the skin, leaving less for the brain. Symptoms of heat exhaustion are fatigue, headache, dizziness, profuse sweating, rapid pulse, thirst, loss of appetite, nauseous, vomiting, and fainting. Heat exhaustion can be treated by getting the person to the shade, cooling them off, increasing fluids, providing a cold, wet towel or ice, fanning, elevating legs above the heart, and loosening clothing. It's important to know that you do not give any liquids containing alcohol or caffeine to the person, and also that the person may need an IV. If the conditions worsen, seek medical attention immediately. If left untreated, heat exhaustion can lead to heat stroke. Heat stroke. Heat stroke is considered to be a medical emergency and a life-threatening condition caused by the failure of the heat-regulating mechanisms of the body due to high heat and humidity. Some things to note about heat stroke is the core temperature rises and the body stops sweating. Heat stroke. The symptoms for heat stroke are skin is hot and dry, flushed, a rapid pulse, confusion, nauseous, convulsions, a rectal temperature above 105.8, and unconsciousness. The treatment for heat stroke is to remove the person to a cooler location, loosen clothing, immerse in cool water, wrap in wet sheets, cold compresses to the head, neck, and groin. Always seek medical attention immediately. Prevention and control of heat-related illness can be achieved by the following: engineering controls, work practice controls, and personal protective equipment. The following engineering controls can be used to prevent and control heat-related illness. General ventilation. General ventilation is used to dilute hot air with cooler air. Works better in cooler climates. Air treatment, air cooling, air conditioning. This reduces the temperature of air by removing heat and humidity. Local air cooling. This cools rooms by providing a portable blower with a built-in chiller. Convection. This can be accomplished by using fans, as long as the air temperature is less than skin temperature. Heat conduction. Insulating the hot surfaces that generates the heat and changing the surface itself. And radiant heat sources, such as shielding, insulation, and surface modification. Any surfaces that exceed 95 degrees Fahrenheit are sources of infrared radiation that can add to the worker's heat load. Flat black surfaces absorb heat more than a smooth, polished one. Cooler surfaces around the worker help because the worker's body radiates heat toward them. Work practice controls that can prevent and control heat-related illness are: perform work activities during cooler periods of the day, minimize activity in hot areas, slow down the work pace, reduce the number and duration of exposures, wear the proper clothing, provide recovery areas, and understand work rate. The fastest way to decrease the rate of heat production is to decrease the work rate. The following personal protective equipment can prevent and control heat-related illness: reflective clothing, auxiliary body cooling, such as ice vests, wetted clothing, water-cooled garments, and circulating air, aprons, jackets, and suits that completely enclose the worker from neck to feet can stop the skin from absorbing radiant heat. However, most reflective clothing does not allow heat exchange through the garment. The reduction of radiant heat must offset the corresponding loss in evaporative cooling. Reflective clothing must be worn as loosely as possible. Where radiant heat is high, auxiliary cooling systems may be necessary beneath reflective clothing. Acclimatization. Individual susceptibility to heat-related illness can vary widely between workers. Workers become gradually acclimatized when exposed to hot conditions for several weeks. Physical changes in blood vessels and in sweating occur to dissipate heat more effectively. When the heat index is high, special precautions are needed to protect unacclimatized workers while they adjust, particularly on the first few days of the job. Gradual exposure to heat gives the body time to become accustomed to higher environmental temperatures. Heat disorders in general are more likely to occur among workers who have not been given time to adjust to working in the heat, or among workers who have been away from hot environments who have gotten accustomed to lower temperatures. Hot weather conditions of summer are likely to affect the workers who are not acclimatized to heat. Reacclimating. Likewise, workers who return to work after a leisurely vacation or extended illness may be affected by the heat in the work environment. Whenever such circumstances occur, the worker should be gradually reacclimatized to the hot environment. After long absences, should start with 50% exposure on day back, 20% per day increase for the next 2 days, and then the final 10% on the third day. Work monitoring programs. It is always important to ensure you are fit to work before the task. The bottom line: excessive heat in the work environment can lead to serious physical harm, and even death. The keys are recognition of the potential and prevention. The following information should be reviewed to heighten heat stress awareness. I would suggest you print the posters and place on a bulletin board at the work site. All employees, managers with a smartphone should download the Heat Safety Tool app for guidance in the field. If you have any questions, please send me an email or give me a call. Thank you.